All right, guys, so today we are going to be doing graphing exponentials and logs, and we're doing it together. Since exponentials is something we have done before, like 2 years ago, logs is the new one, but I want to connect the two so you get a better grasp on where logs come from, okay? So let's start out with exponential right now. And we're also going to relate it, of course, to transformations. That way we have that connection of graphing all types of functions using transformations. So with transformations, we use the parent function. So let's start out exponential parent function. So you see that we have this sort of looking J, right? And this keeps going up and to the right. So it keeps going that way. Now this one here, as you can see, it's scooping down and it keeps going left, but it never touches or crosses this x-axis right here. Does anyone remember what this is called? Remember, this is called an asymptote, where you get really, really close to it, you hug it, but you don't actually cross it. So with exponential, there is a horizontal asymptote, okay? And the domain will always be negative infinity to infinity. Now the range will vary based on the equation we have. So exponential, how do you know it's exponential? Well, it's in the form of b to the x, b being your base. And we're going to keep it as big B, so that way when we do our transformations, we don't confuse the little b and little b. Little b and big B. All right, so parent function. What happens is our x values, we're going to use -1, 0, and 1. No matter what, when x is -1, the parent function of our exponential function will be 1 over b, whatever the base is. At 0, the y value would be 1. And at 1, the y value will be that base number. So, and then we'll do our transformations off of there. Now, let's go over that really quickly. So with exponential, this is where our transformations come up. Remember, the a in front makes a vertical stretch. And also, if it were negative, it flips it. It flips it over the x-axis. So up and down like that. Okay. Now, usually with transformations, I always talk about the inside versus the outside. Okay, well, with exponentials, our inside would be what's in that exponent, what is done to x. So of course, not inside, that b right there, that lowercase b, is a horizontal stretch or a flipping over the y-axis. C moves it left or right, and we have to remember to always do that opposite, right? Same thing with little b there. We always divide or do the opposite, right? And then on the outside here, we have a vertical shift that moves it up or down. Okay, that big B again being our base number. That affects the parent function table. So let's do a couple examples now. All right, so here we have number 12. I know the numbering is incorrect, but don't worry, let's just go with it. The first thing we're going to fill out is what is the base? What is the base of our exponential? Our base of our exponential is 2. Now, what I always like doing is knowing that it's exponential, I like graphing or making a sketch of my parent function and my asymptote, just so I know I don't rearrange it. This will make sense when we get to logs. So I also like to put down what the transformation is supposed to be doing, so that way I can double check my graph at the very end. So when I subtract from x here, that's moving it horizontal. And we always do the opposite. So that's going to be moving it right 1. And subtracting 3 at the very end does it down 3. Okay, for an exponential, the domain is always negative infinity to infinity. Our asymptote, I'm going to have you guys write this down just so you don't confuse the two. Our asymptote is going to be horizontal. Now, why do I say that? Why do I want to point that out? Well, first of all, horizontal is always y equals. So when you have your horizontal slope like this, which way can I move my arm in which it changes? Because if I move left and right, am I really changing? No, because really my arm continued down both ways. So I have to move up and down. So the way the asymptote for an exponential moves is up or down. So remember, the parent function was at 0, and this function makes it move it down 3. So that means the asymptote now is at -3, because again, that horizontal asymptote is moving up or down. Okay, I have 2 graphs because we're going to do our transformations on one and our final coordinates on the other. So let's do our parent function. Our parent function, of course, for our x's is going to be -1, 0, and 1. And remember, from the other side, if you have to flip it over, the y value is 1 over b. So in other words, that's 1/2. At 0, it's 1. And at 1, it's b. Okay, this changes when the base changes. So that's why we put it in our notes as 1 over b and b. If we kept going, this would be b squared, b cubed, so on and so forth. All right, let's do our transformations. So on the inside, right here, because the inside is that exponent, where it says a -1. But what do? Is we're going to make we're always going to do the opposite. So we're going to add 1 to the x because it's on the inside. Now on the outside here, we do that to y, and we do exactly what we see. So we're going to subtract 3. If you have to use your calculator, go right ahead. I'm going to do these values quickly, so that way I'm able to keep this lesson short. So this is going to be 0, 1, and 2. This is going to be -2.5, -2, and -1. So this is why I have this table, just for you to identify that your ending coordinates are 0, -2.5, 1, -2, and 2, -1. Now, when I graph, I always graph my asymptote first. So our asymptote's at -3. So 1, 2, 3. Remember, this asymptote allows me to know, like, hey, it's never going to cross this. Okay. And now I'm going to plot my coordinates. Of course, with fractions or decimals, make sure you just approximate. So at 0, -2.5, there. 1, -2, and 2, 1. Now, when I look at these coordinates, let's keep in mind that when I connect them and I continue to the left, I'm not going to cross the asymptote, I'm going to hug it. But the other part, I'm going to go up into the right. And what do you know? Run my parent function, over right, down 1, we're good to go. But one more thing, let's talk about our range. Our range, of course, is our y values. How far down? How far up? So how far down does it go? It goes to -3. How far up? It goes to infinity. I put parentheses there because it never reaches -3, right? Otherwise, it would be a bracket. Do you guys see a connection? My range is from the asymptote. Okay, so keep that in mind. That will help. Let's try another one. Okay, what we're going to do here is this negative out front. What does it do? It flips it over the x-axis. Adding 1 to x, what does it do? Left 1. And adding 1 on the outside makes it go up 1. Our base is that 3. That's what the 3 was there for. Okay. Again, we're doing exponential, so I just want to picture it. Horizontal asymptote. Okay. Now, domain will always be -infinity to infinity. We're doing exponential, so the asymptote is horizontal, which means it's y equals Okay, now remember, horizontal, we can only move up or down. And according to our transformations here, we're going up 1. So from 0, we go up 1. All right, let's talk about our table. I know I'm going a little quick. I'm sorry for that. So pause it, rewind it if you need to, okay? Exponential, we use the values for x of -1, 0, and 1. Why values? Remember, at -1, it's 1 over b. Our b in this case is 1/3 or 3. At 0, it's always 1. And at 1, it's b. So at 1, it's 3. Now go left to right. So on the outside here and left, we're multiplying by -1. Do we do that to the x or the y? It's on the outside, so we do it to the y. So we're going to multiply by -1. Next, we're adding 1 to x, which is the inside. So we do it to the x, but we do the opposite. So we're going to subtract 1. And last but not least, this adding 1 is to the outside. So we do it to y. So we're going to add 1. I'm going to go through these quickly. Use your calculator if you need to. -1 minus 1 is -2. 0 minus 1 is -1. 1 minus 1 is 0. I'm going to multiply these by -1 first. And then I'm going to add 1. So when I add 1 to this, I get 2/3. I get 0. I get -2. Okay, so my ending points here are -2 and 2/3, -1 and 0, and 0, -2. Okay, let's keep in mind what's going to happen here. So we're going to take this graph and we're going to flip it over the x-axis. So it's going to be somewhere down here, right? And then we're moving left and up. All right, let's see if this happens with our coordinates. Let's graph our asymptote first. That's at 1. Remember, we're going to hug this line, but we're not going to cross it. Question is, are we above or below? So we get -2 and 2/3. So like I said before, estimate where that coordinate is. -1 is 0, and at 0 it's -2. So as you can see, when I connect these 3, that means on my left side, I am going close to that horizontal. I'm hugging it, the asymptote, not the horizontal. And then on the other side, I'm going to continue down and out. Did it flip? Yep. And it moved to the left, and it moved up above the x-axis. So range, though, be careful because now it's flipped. The lowest coordinate or the lowest spot it will go to is -infinity. And the highest it goes to is 1. Very good. By the way, the bell's going to ring here in a minute. So if you hear it, just take a moment and then we will continue. Now, I know this looks like a different section, but I wanted to connect the two. Okay, so why would I connect exponents and logs? Well, I'm going to use the word inverse because they are actually inverse functions of each other. So we've done inverses in the past. We've done inverse operations. We've done inverse functions. So if you had to take a moment right now and you had to simplify what inverse means, what would you say? So think about this. If you can't think of anything, what if I said, what is the inverse of multiplication? You would say division. Okay. If I said, what is the inverse of addition? You would say subtraction. So when you think about it, inverse is what? It's the opposite. It undoes what's going on. So example, and I'm just going to put it up here so you can see. If I said x squared and I said what's the inverse of x squared? You would tell me the inverse is, hopefully you said it, square root. Just like x cubed, what would be the inverse of that? Cube root. So every function has an inverse. It has a function that undoes the other one. So with exponential, which actually we've known for years, we haven't gone over what the inverse function is. What it is logarithms, okay? So, and this also makes sense if you look at it, because look at this curve. It's almost like our exponential, but it's not quite there. It's because if you ever compare inverse graphs, they actually, so if this is our exponential, the inverse function will always reflect y equals x. Okay? And when you know, there is our log. Okay. So the other thing that you might remember is at the beginning of the year, we talked about inverses, right? We said if we had a function that had the coordinate x comma y, the inverse, which could be written as f to the negative 1x, can be written as y comma x. We just switch x and y values, okay? So hopefully that kind of looks familiar. That is what we're going to do. If you look right here in logs, what happens is our domain is now having to stop somewhere where our range is negative infinity to infinity. And instead of a horizontal asymptote, it has a vertical. So that's why I was making it very important that we look at what type of asymptote it is. So as you can see, it gets really close to y equals 0, or x equals 0, sorry. And on the other side, it continues going to the right and up. So what does that do for a parent function? Well, as you can see, doesn't this look familiar? It looks like our exponential parent, but our x and y is flipped. And that makes sense because it's the inverse of it, and inverse is switching our x and y. So now when we deal with the parent function of log, our y's are going to be the negative 1, 0, and 1, and our x's are going to be the 1 over b, 1, and b. Now, when it comes to our transformations, this is how it looks. This subset is our base. The inside, a little bit easier to look at the inside, right, because of the parentheses. The other thing I want you to keep in mind is that when sorry, I got interrupted. Okay, so there's our A, our B, our C, and our K are up and down, left and right, flipping this and that. But one thing I want you to keep in mind that was very important, that this base right here, if you see log, and then let's say we see X right here. Sorry if this sounds weird when I put it together, my computer stopped. So here we go. If you do not see the B there, that base value, it automatically means 10. Okay, so again, if you just see log of something, or let's say 2 log 3x plus 7, when there's no subset, no base, that's automatically the base is 10, okay? So we're gonna do one example of log just so you can see how to set it up like we did the exponential. So pause your computer right now to write down this example because I'm going right into the example, okay? So again, the B comes from that subset. So this is going to be a base 2. Now let's go through this. On the inside, it says -1 or -1. So we're going to go to the right one. And we're adding 3 on the outside, so we're going up 3. Now, remember before how I would take the parent function and just do a sketch of it just to remind myself? Do that on the side again on purpose because our log is going to be like this and our asymptote is going to be vertical. Okay, so keep that in mind. This is how it switches. So now we have to switch. Our range for log will always be negative infinity to infinity. Our asymptote, we just said, is vertical. Now, when you do vertical asymptotes, that's always x equals. Now, let's look at it again. This is our vertical asymptote. Which way can it move? It can move left or right. So when I go back up to my transformations, as you can see, I'm going to the right one. So I'm going to add 1 to 0. So our vertical asymptote is at x equals 1. Now, as you can hear some announcements. Okay, so on the table, remember what side can we automatically fill in? Because we're switching and we're doing inverses, that means we're automatically filling in the y with -1, 0, and 1. Remember, exponential, we filled in the x values. So here, at y equals -1, our x value is 1 over b, so 1 over 2 in this case. At y equals 0, we get the value of 1. And at y equals 1, we get the value of b, which in this case is 2. Now let's move it to the right one. So we're going to add 1 to x. Move it up 3, so we're going to add 3 to y. Okay, I'm going to do this quickly. This is 1.5, 2, and 3. And on this side, we have 2, 3, and 4. Okay. Now, of course, are there more transformations? Yeah, there could be more transformations. So let me start doing our graph. Of course, it's not going to be as pretty because I'm freehanding it. So do our asymptotes first. Where is our asymptote? It's at 1, and it's vertical. So I've got to go up and down at 1. This is very important. This is where most people switch the graphs and actually graph an exponential instead. Okay. Oh, I switched my colors. All right. So coordinate pair at 1.5, we're at 2. At 2, we're at 3. And at 3, we're at 4. So as you can see, if I connect these two, as I go to the left, I'm going to hug the asymptote. And as I go back out, I'm going out and up. Okay. And there's our log. Very good. Look at our parent, look at our log. We didn't flip at any time, so it should go in the same direction. Now let's look at our domain. How far left to how far right? Well, how far left does it go? It goes to 1, doesn't hit it though, it gets close to 1, and it goes all the way to the right, which is infinity. Okay. Now, one more thing, because when I am not here, that's all I wanted to stop sharing, and now I look crazy. I want to show you what questions I want you to do, so that way you know you're doing the correct ones on your packet. Thank you. Okay. So you should have done the first page on your packet. You're going to do all of this page. This is just using a calculator. This is matching what exponential with what graph. These two are graphing exponential. Okay. You're going to skip this page. Do not do this page yet. And then graph your logs. Now, as you can see, I changed this. Do not do ln. I'll explain that next class. I want you to change it to log base 2 x plus 4. And you're going to graph these. This is your homework. All right, let's try that out.